Hello class, today we're going to talk about how to calculate percent yields and find unlimited reactants. Whenever you see a learning check in the video, press pause, try to complete the learning check, and then press play to resume the video. To calculate a percent yield, you use the actual yield over the theoretical yield. Your actual yield comes from your reaction. After you do your experiment, how much do you actually obtain of your product? The theoretical yield is the yield that you obtain after you do all your calculations from a balanced equation. So here's some steps when calculating your percent yield. You're going to state the given, write a plan, write the molar mass. Remember that molar mass is grams over moles or mole over grams. From the balanced equation, you're going to solve for the percent yield by dividing the actual over the theoretical and multiplying it by 100. So in this problem, it's asking you to calculate the percent yield. It gives you 50 grams of LiOH and it has 72.8 grams of LiHCO3. Now remember some of your conversion factors to actually solve this problem. So our first step is state what is given in the needed quantities. So you are given 50 grams of LiOH in your reactant and 72.8 grams of LiHCO3, which is your product. It's asking you to find the theoretical yield and the percent yield. And it also gives you an equation. Make sure your equations are always balanced before moving forward. Now we're going to use our different conversion factors to get to what we actually need. If we need grams of LiHCO3, remember whatever we want to cancel out goes at the bottom and whatever we're trying to go to goes at the top. So we're going to use molar mass, mole to mole, and molar mass again. Remember molar mass is grams over mole, and you always use mole to mole when you're introducing something new. Now, when you calculate the molar mass for LiOH, you get 24.0 grams. And for LiHCO3, you will obtain 68.0 grams. The mole-mole ratio is 1:1 for LiOH and LiHCO3. Remember, whatever you're trying to cancel out goes at the bottom, and whatever you're trying to go to goes at the top. So we're trying to cancel out grams of LiOH. So grams of LiOH will go at the bottom. Then we're trying to cancel out mole of LiOH. So mole of LiOH will go at the bottom. Remember that this is your mole to mole ratio. We're trying to go to grams of LiHCO3. So that's why it goes at the top. And we get a sum of 142 grams of LiHCO3. So remember in our problem it gave us 72.8 grams of LiHCO3 was actually produced. So that's why we have 72.8 as our actual and 142 as our theoretical, because we just calculated 142 grams of LiHCO3 is produced when we can react 50.0 grams of LiOH. Once we do 72.8 divided by 142 and times it by 100, we obtain an answer of 51.3%. That is our percent yield of the reaction. Now, we're always trying to get close to 100, but we know that that normally doesn't happen in the lab. So 51.3 means that you lost almost half of your product. Now, we could have lost half of the product, or we could have just had a limited reactant. A limited reactant in a chemical reaction is the substance that is used up first and limits the amount of product that we can form. All of the other reactant is called the excess, or what is left over. Remember, in your experiment that you're trying to obtain, you want to eliminate your excess But you also don't want to create a limited reactant where you don't obtain all of the product that you're trying to obtain. So let's take this example. The question asks how many peanut butter sandwiches could be made from 8 slices of bread and 1 jar of peanut butter. Now, if each peanut butter sandwich requires 2 slices of bread, that means that we can only make 4 peanut butter sandwiches because we only have 8 slices of bread. Even though we have more peanut butter to make more sandwiches, we ran out of bread. Hence, the bread would be the limited reactant. So another way of looking at it is, let's say that we still had 8 slices of bread. We still want to make 4 sandwiches, but we only have 1 teaspoon of peanut butter. Now we could be selfish and try to split the peanut butter up off over 4 sandwiches. But let's say it takes 1 tablespoon of peanut butter to make 1 sandwich. So therefore, the peanut butter would now be the limited reactant and the bread would be the excess because we have 6 slices of bread actually left over. So our bread in this example would be the excess. Now, when we're calculating the limited reactants, here are some steps. So, we're given this problem. Calculate the moles of product that can form given 3 moles of CO. So, CO is our reactant with 5.00 moles of H2, which is our other reactant. The question is actually asking you, out of the 2 reactants, which one would limit you from actually calculating what you want? So your first step would be to ask, what is the mole to mole ratio? And what is the number of moles of CH3OH that you're actually trying to form? And if you know how much you're trying to form, what would actually limit you from actually forming what you want to form? So looking at the mole to mole ratio, for every 1 mole of CO, you have 1 mole of CH3OH. For every 2 moles of H2, there's 1 mole of CH3OH. Now, if we have 3.0 moles of CO, we can actually produce 3 moles of CH3OH. If we have 5 moles of H2, we can produce 2.50 moles of CH3OH. Hence, the H2 would be the limited reactant because you can only produce 2.50 moles of CH3OH if you only have 5.0 moles of H2. So this chart shows you that the CO would be the excess, H2 would be the limiting, and the only amount of product that you can produce is 2.5 moles of CH3OH. So here's some steps when calculating the mass of product from the limited reactant. You're going to state the given, use coefficients to write mole to mole factors or molar mass, calculate the number of moles for your reactants and your limiting reactants, and then use molar mass to actually convert smaller number of moles to product to grams. So let's look at this problem. It says how many grams of CO can be produced from a mixture of 70.0 grams of SiO2 and 50.0 grams of C. Now, if I'm given 70 grams of sand, which is SiO2, and 50 grams of carbon, which is C, it wants me to know what is my limiting reactant. So the first step is to calculate the molar-mole factors or write the molar mass. Remember, molar mass is, let's say I have SiO2. Si has 1 atom, and in SiO2 we have 2 oxygen atoms. You take Si and multiply by its mass, oxygen and multiply by its mass, and calculate it. When you calculate them together, you should get 60.1 grams of SiO2. Carbon has a molar mass of 12. Now you would take how many grams of CO? Remember, we need to use molar mole factors. Molar mole factors are used when we need to introduce anything into our equation. So for every 1 mole of SiO2, there's 2 moles of CO being produced. And for every 3 moles of carbon, there's 2 moles of CO being produced. Remember, whenever we're trying to do a word problem, pull out what you need. So we need 70 grams of SiO2 and 50 grams of carbon. Whatever you're trying to cancel out goes at the bottom. Whatever you're trying to go to goes on the top. So in this case, our limiting reactant would be the sand, which is SiO2, because you can only produce 2.32 moles of CO if given 70 grams of SiO2. So the last step would be to actually calculate how much CO could be produced in grams. So in our last step, we found out that 2.32 moles of CO can actually be produced if we look at our limiting reactant, which was sand. So if we take that with the molar mass, which is carbon has 12 and oxygen has 16, which gives us a total of 28, and we times that by 2.32, we can produce 65.0 grams of CO.